Hello. Now it's 4 o'clock. Welcome everybody to come to this the night for AP Computer Science A. My name's Eric Chow. I hear the echo. Let me try to tune down the echo. I'm sorry. Let me tune down the echo. Basically, there seems to be a delay. Let me actually tune my broadcasting system. Okay. Sorry for that. Actually, this. Let me see. I'm tuning for the delay here. Let me see. Features. Okay, let me see. Setting. Latency. Let me see. Channel setting. Okay, sorry for this. Actually, there are some delay. Let me try different things. Okay. Let me actually tune for the speaker so that I don't hear the feedback to my own system. So let me actually set it to here. Okay, it's okay. Let me go back to this lecture. So welcome to this AP, the night before AP Computer Science A. My name is Dr. Eric Chow, and currently I'm a adjunct professor at Lewis University. And today I'm proud to present to you this the night before AP Computer Science A to help you to get prepared for the AP exam. And my website is over here, the eco24.com. And you can also reach me at ecacademy.us, the United States, ecacademy.us. Okay, so these are the contact information. And from this eco24.com, you can find my contact information. Okay, let's get started. First, this is my website, ecacademy.us or eco24.com. And my email, 510 is my zip code, and it's echow510@gmail.com. And my Facebook link is over here. So my name is Eric Chow, and actually I'm currently IEEE senior member, and IEEE is the leading institute for the electronic engineer. And also it's also a big organization for computer science engineer as well. And I'm also a current member of the Computer Science Teachers Association. And I got my undergraduate bachelor degree from National Taiwan University with the computer science and engineering. And I graduated from USC, the Southern California, with my master degree in EECS and also my PhD degree in EECS. And currently I'm with IEEE. And topics. Today, I would like to go over the multiple choice problem solving skill and free response problem solving skills, and also give you the review for the different chapters. Okay, so you will have a comprehensive review. Basically, will be get you to prepare for the exam. But I try to stay on the fundamental part because this is the last day review. So it would be better that we focus on those fundamentals and try not to work on too much the fancy part, because those may distract you to some direction that actually doesn't help you to solve problem in the real exam. So first thing that I want to let you know is that for the new coming school year 2019 and 2020, there are updates for AP Computer Science A. And these are important things that you need to know, because very likely tomorrow's exam will be affected by these updates. Number one, uh, before we have this update, the exam actually is more or less not aligned with the course material. Okay, so every teacher try to teach the kind of material they want to have, and the exam actually just randomly picks some question for you to do it. And although it actually will designed to cover different topics in the AP Computer Science A, but it is not well organized. So sometimes some portion are more emphasized, and it may not be as good. Okay, so for the coming school year, the new AP Computer Science A will be in units, and these are the different units. And what I see from here is actually the abstract class and the interfaces are actually not in the new modules. So basically, that's one major change. But for me, I would say if you want to really learn Java object-oriented programming, that two module still be very essential. So I will continue to teach that for my curriculum. But I think that for the exam purpose, next year may not need it. But for this year, the abstract class and interfaces are still the important topic to be covered. Okay, so still need to take care of them. And for the free response problems, I would believe that maybe this year it will follow this guideline for the next year. So basically, there will be 4 questions, and each one of them may have the same kind of the topics. Okay, so basically, you need to prepare for one question, maybe in question 2, to implement a class. Okay, so that's one possible direction. But sometime in the past exam, they may or may not have the class design problem. But from the next year, there will be a class design problem for each AP Computer Science A exam. So basically, this is will be the new format. Okay, and number one would be methods control structure. So basically, this one will be testing you the if loop, if a structure or else structure, and also the method design. So there will be one problem on this. Okay, for the for loop, while loop, and if then else, those kind of combination for programming structure. And then two more problems on data structure. It will be array list, and the 2D array. And these may be also in combined with the classes or objects. So basically, these are the breakdown for the four problems, and I would assume that this year may have a very high chance that these four FRQ problem will be followed in this. Okay, so basically, for the multiple choice, it will be taken the material from different units and have 40 questions, and 40 questions will be need to be done within 1.5 hour. And if you divide it, you have 90 minutes to work on it, and then you have 40 questions. So each question you need to finish it within 2.5 minutes. And the first 20 question may be actually easier, and the last 20 question may be harder. So you probably need to work on the first 20 question within maybe 30 minutes. Okay. And then next 20 minutes, you may need to spend about uh, 45 minutes. So you have another 15 minutes to work on the review for the questions. And the free response problems, actually you have 4 questions, and each one actually take 9 points. So the full score is 9 points, and 4 questions you will have 36 points, and then you may end up with 33 over 36, and then there will be 4 readers point. It will be determined by the reader. So very likely the reader will decide 10% of your FRQ, and usually they will depends on the score you have. And the way that most reader would do would be, if you really solve the problem and you know what you are doing in that question, they will give you the reader point. Okay, so usually the student who get 7 out of 9 or 6 out of 9 or 8 out of 9 will receive the reader point, but 2 out of 9 or 3 out of 9 maybe not. Okay, so basically that reader point, based on my experience, will be depending on whether you really had the main algorithm working for the question or not. If yes, they will give you the reader point. And but that you have no control on this. Okay, so if you want to score 5, my guideline usually is you need to score at least 30 or more on FRQ, 35 on multiple choice. Then in combine you will have 65 points, and that would be a safe score for getting 5. Okay, so in order to get 30, you may need to have 9, 9, and then 2 easy one you need to get 9, and then you have a middle one you get 7, hard one you get 5, or if don't you cannot get 5, you get 3. And in that case, you would have 9 plus 9, 18 plus 5 plus 7, so you will have 25, and then you have 3, you have 28 plus 2 reader point, you make 30. Okay, so 9, 9, 7, 3 is enough for you to make 30, and then you need to try your best to get your multiple choice to over 35. Then you will have high chance to get um, a score of 5. Okay, to get score of 4, I would say if a score of 50 would be enough. Then you need to have 30 on the multiple choice and 20 on the FRQ. But usually it's the breakdown. Okay, and 3 and below I don't explain it. Okay, now then in between the two sections you may have half an hour usually for you to break. Okay, so at that time you probably don't think about anything at all. Try to get yourself relaxed, because the next 1.5 hour you need to come back for your FRQ. So basically the time management is very important. Okay, so now for today's talk, I would start to talk about following the units I have in my online course. So basically, unit 1 will be the elementary programming. Unit 2 will be structured programming. Unit 3 will be data structure. Unit 4 will be object-oriented programming. Unit 5 will be the algorithms. So basically, I follow the structure of my course and review topic by topic. Okay, so this topic by topic review will be helping student in multiple choice section. Okay, so we will go through the base fundamental ideas one by one. Okay, so you will have the chance to review everything in a short time. So this video we will have it recorded, and basically we'll also have the live broadcast, and you will be able to see it online. Okay, you'll be able to see it online, and then it will help you to study. Okay, and for the free response question portion, I may try to my best to put some code when we review these different units. Okay, so before we get started, today we will use the BlueJ as our editor. And right here, I have the whole collection of the AP review algorithms. Okay. And one thing I would suggest is like the binary search algorithm. Okay. Binary search algorithm, linear search algorithm. Okay. Linear search algorithm, bubble sort. Okay. Bubble sort. And insertion sort. Insertion sort. And merge sort, merge sort, okay, and selection sort, okay. These different sorting, basically, you have to memorize them by heart. You have to memorize them by heart, okay. And some of the basic array processing, like finding the maximum, finding the minimum, fill in data, these algorithms also you need to memorize them by heart. Okay, so for me, usually I give away this combo of the algorithm to my students, so they get the whole package and practice day and night for it. Okay, and they are about maybe 35, 40 different algorithms for at AP computer science level. So that's the way you train your FRQ. And usually in the real exam, you may have one problem that you need to invent a new algorithm. And that one you can try to get 5 if you can, okay? If not, you try to get 3, but don't leave it blank, okay? For any FRQ question, as long as you write something on it, you will get some point. And multiple choice, there's no deduction, so you shouldn't give up anything. Okay, just try to put something on the paper. Try to bubble something on your multiple choice. Don't leave blank on any question. Okay, there is no deduction on multiple choice, and also the FRQ, they will score you some point as long as you write something. Okay, so that's the guideline uh, for scoring. Okay. Now let's go back to our unit 1. So unit 1, elementary programming. Elementary programming means the basic Java language, the data types, and also the basic Java environment, the APIs. Okay. First one, the basics. Every AP exam question uses at least one of the following: the type and identifiers, operator, and control structure. Okay. So basically, you have to take care of the data type, primitive data type, okay, or reference data type. They work differently, okay. And operators, what operator are you using? Is that a legal operator or legal function or not? Okay. Control structure, is that appropriate? Does it actually get the index or get the element? You have to make sure you understand it, okay. So these are the basics. First, identifier. Identifier is a name for variable, parameter, constant, user-defined method, or class. The convention says that identifier for variable and methods will be lowercase, starting with lowercase, and the second letter will get what? Capital letter, leading capital letter. So something like get name, find service, area, pre-text total. So text total, TT will be in capital. But if someone doesn't follow the rule, it is actually legal. Compiler will pass it. Okay. Okay, so basically we try based on the compiler's result, not based on the naming convention. It's one thing you need to know. Okay, primitive data type. There are 8 primitive data type. Short, byte, short, integer, long. These are 4 integer type. Float and double, that is the real number type. But basically, only integer and double will be tested. So you basically need to know int, double, char, or character, boolean, the 4 data type. These are the basic 4 data types you need to be tested. So here will be the numerical data type and their operations. So take care of your integer and the floating point. So integer is a 32-bit data, and it is signed. So basically, the number coming from the minus something like this to positive something like this. So here, let me use my whiteboard. Okay, let me use my whiteboard. So let me actually change the. Let me see. Increase the size of the point. Okay, I increase to 4. Okay, the black one. So here the integer. Let me see. Okay. Oh, let me see. Okay. Sorry. Sorry for that. Okay. Let's see. Okay. So basically, integer. Let's see. It doesn't take my. It doesn't take my. I have a touch screen, but it doesn't take my touch screen. So the integer actually the range will be. The range will be. You have 32-bit, right? So the maximum number will be 2 to the power 31 and then minus 1. Okay, the negative number will be minus 2 to the power 31. Okay, if it actually go overflow, basically it would may flip the polarity of the number. Okay, that's something you need to know. Okay, okay, here let me try some different tool to help us. Okay, let me try if I can get another whiteboard. Okay, this one actually not really good. Let me try some other whiteboard. Okay, this one actually not really good. It doesn't take my. I used this before. Okay, so let me try this one. Okay, let me change it to pixel 3. Okay, that's about good. Okay, here. So the integer, the number is 32-bit. Okay, and 32-bit you divide into half. Okay, upper half is positive, lower half is negative. Okay, so you start it from 0, 0, 0, 0 up to some number. Okay, so this one actually you can have 0 to 2 to the power 31 minus 1. Okay, negative portion it has a leading bit of the 1, and it will go from minus 1 down to minus 2 to the power 31. Okay. Okay, so this whiteboard is good for us. Okay, let's go back. Sorry for the delay. Okay. So these are different data type. Now the next one is we have this typecasting. Okay, we have typecasting. So there are two types of casting we may have. One is explicit typecasting. The other one is implicit typecasting. Uh, Implicit typecasting means you don't need to do anything, and the data will actually convert for you. So for those kind of the casting, it would be something like this. Okay, so from the left hand side to the right hand side, uh, the data type will actually expand. Okay, it go into the wider range. So from integer converted to double is okay. You will have the implicit casting. From right to left, no way. You have to do explicit casting. So for explicit casting, you will have to write. Say you have the integer x equals double 3.0. Okay, so basically this one, I'm sorry, this one is not double. I have to erase it. Okay, sorry for that. So actually your 3.0 is a double value, but you want to cast it to integer. You have to put a int there, right? So this is called explicit casting. Your floating point number 3.0 will be converted to integer. Okay, so if you see something called 3.0, 4.5, it's all representing the double type in AP exam. Okay, if it is just write 3, that means integer. Okay, you have to follow that. But this happen in Java language. When you print out, you will follow this type of standard. But in C language, C double plus language, it's not like that. Okay. But for the AP exam, when you see something without decimal point, it means integer. Okay. With the decimal point, it means the floating point number. But from integer conversion to double, it is okay to use implicit casting. Okay, the conversion of the data type is automatic. But from floating point number to integer, no way. You have to put your uh, type casting in front of the data. Okay. So now let's go back to here. That's casting. Okay. Then the next one is the storage of number. Okay, storage of number we integer we use a 32-bit. Okay, we have double use a 64-bit 8 bytes. 6 byte. Let me see. 64-bit actually is what, or yeah, it actually is a six. Let me see. 8 by 8. Yeah, it's actually 8 bytes. Okay, it's a double size of the integer. Okay, and the exponent. Actually, this is sine times mentisa times 2 to the power exponent. This one is not correct. Okay, I copy this one from somewhere, but this equation is not exactly. It is somewhat close to this one, but not exactly the same. So if you are interested in the format you want to study for double type, you have to refer to IEEE 754 for the data type. Okay. And but something to remember is that floating point, you would have run-off error. So if you do arithmetic operation too many times, the run-off error will accumulate. Okay, and when because it will accumulate, so try not to use double type for equality checking in the while loop or if statement. It sometimes will surprise you. Okay, and also in exam, don't do that as well. It's not a good way. When you want to compare data in double type, maybe you use the inequality sign that greater than or less than would be better. Okay. So in integer, you have the integer that mean value, that would be the minimum value, that would be the minus 2 something value, that the most negative number. integer, the max value will be the 2 to the power 31 minus 1. Okay, and the mean value and the max value also exist in the double class. So when you do the searching for searching algorithm, these numbers are very useful. Okay, so the negative number for Java is using this one called two's complement. So a number, the negative number representation will be stored in two's complement format. Let me explain this a little bit. Okay, let me actually print on my whiteboard. Okay, so right here, basically right here, let me explain it. A number, you have the x, right? Say, let me do what 7. Let me see. Let me do 5. Okay, if I have a 5, so 5 will be 0 1 0 1. Okay, and that's use a 4-bit system. Okay, so 4-bit system, the maximum number will be 1 1 1 1. Okay, anyway, so in 4-bit system, I have an x, right? And I try to represent my minus x. Okay, so my minus x, because I don't have the sign, so to represent minus x, I use the 2 to the power 4 minus x as my minus x. Okay, so when I have my x plus my minus x, it will sum up to 2 to the power 4. That would be 16. Okay, and that will create overflow, so it will be omitted. Okay, and why this will work? Let me show you. Okay, why this will work? Because you have a x equals 5, so your x equals 1 or 1 1. Okay, and your 2 to the power 4 minus x will be, you have 5, so the other one 2 to the power 4 is 16 minus 5, you get 11, so you should be 1 0 1 1. Okay, you sum this up, you get 0 carry 1 0 carry 1 0 carry 1 0 carry 1, and you have the overflow bit over here. So you down this one becomes 0. Okay, so basically this can be used as the negative number representation for my original data 5. So this one's 5. Okay, and this one's minus 5. The sum is 0, and minus 5 is represented by 11. Okay, so 5 plus 11, you get 16, and I dump the leading bit, I will actually consider this to be 0. Okay, this is so-called two's complement. And to find your two's complement, you basically do the following thing. Your 2 to your 2 to the power 4 minus x will be 2 to the power 4 minus 1 minus x plus 1. Okay, so this is called two's complement. This one is called one's complement. So this one's complement would be this number 2 to the power 4 divided by 2 minus 1. It would be 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1 plus 1. This one is 1 1 1 1. So basically, use 1 1 1 1 minus your x is 0 1 0 1. You get 1 0 1 0. This is called one's complement. Plus 1, it becomes two's complement. It becomes 1 0 1 1. That's your 11. Okay, that's the way you can find your negative representation using the two's complement. So basically, it's not that hard. Okay, it's not that hard. You use the O1 bits, right, and then minus your current data, and you get this. But this one actually, if you actually look at it, it actually is the bit flip. So basically, you find your bit flip plus 1, you will get your negative number representation in two's complement. So to be short, backflip your two's binary representation, and then plus 1, you will get your two's complement format, and that is the representation for the negative number in computer. And here I use the 4-bit system, but in real world, in the Java environment, we should use 32-bit format. Okay, and here because of the limitation of space and for the simplicity of the presentation, I use a 4-bit system. So here, actually, as you can see, the 4-bit system is like this. The negative number are, this is over here. Okay, this is using 4-bit system. Okay, right hand side the statement using 8-bit system. So your 5 minus 5 is over here. Okay. So next one is the conversion from decimal to binary number. So this one it show you use this 156 divided by 2 and you get a number and divide by 2. So let me exercise this as well. Okay. So here, if you have a number, say 57, you try to convert it to binary number. So you have 57 divided by 2. You got 28, remainder 1. Okay, so this one is A. This one is a B. This one is a Q. This one's a R. So A equals, I'm sorry, let me see. A equals B times Q plus R. Q is quotient, R is remainder. Okay, so that's the operation we are using. So with that, okay, let me actually erase this. Okay. Okay, so basically we get the first division done. Okay, so we get that one, and after that we continue to do division. Okay, after that we continue to do division. Divided by 2, you get 14, remainder 0. Divided by 2, you get 7, remainder 0. Divided by 2, you get 3, remainder 1. Divided by 2, you get 1, remainder 1. And then you read from here to here. So the number is 111, 001. Okay, that's the way you do conversion from decimal to binary. You basically do series of division and then take remainders, leave it there, and then you read it from here to here. Okay, and then you read it from here to here. And there are some problem. They do need you to convert from decimal point number to binary number. And with the binary number, you convert it to your hexadecimal number or your octal number. Say you have one, you want to convert your binary number to hexadecimal number. Okay, let me see. Okay, this is actually 9, 10, 11, 12, 13, 14, 15. Okay, so here you try to convert it to hexadecimal number. Every 4-bit you group one, make one group. Okay, every 4-bit you get make one group. Okay, let's add one more bit. Okay, that's 20 here. Every 4-bit you get one more group, one group. Okay, so this one is a 9. This one is 10. So 10 means A. This one is 11. We call it B. This one is 6. So this number will be 6BA9. Every 4-bit it group them together. If you need to convert it to octal, usually they don't test you for octal, but if they do, group 3-bit together for the octal number. Okay. But I don't continue to explain octal, okay? Because usually it doesn't test you for octal. And hexadecimal is needed because it is for the color representation, okay? So that is conversion from decimal to binary. And you also have this binary conversion to decimal, and you just use the weighted sum. Okay, you use your weighted sum that would actually help you to convert your binary number into hexadecimal. I'm sorry, your binary number back to decimal. Okay, sorry. Okay, next one. Constants. Constants are variable that you cannot change. So you can assign the constant value only once. Okay, you can only assign it only once. Okay, and after that you can no longer change. After that you can no longer change. Okay, So basically, the size of this one usually you can declare it like this. But this one is a constant variable, but it actually is an instance constant variable. So usually you should do final static integer and then the variable name. So it is a variable and it can be assigned with a value, but you can only assign it once. That's called constant. Okay, and usually you use a final and static data type for it. Okay, you usually use a final static data type for it. And you can also have the final static double data type that actually is fine. Okay, and constant usually, if you have the instance constant, that is fine. That is, the constant only exists when uh, the object exists. Okay, but if you want to have the class level constant, so you can actually access by other class, then you actually want to make it final static. So basically, final static variable, it is a constant variable, and it can be shared by different class. So usually, if you have a class A, if you have the class A, and you declare something called final static integer A equals 3. I'm sorry, let's call it AA. Something like that. So from other class, you can use A dot AA. Okay, here is the class name. So class name dot variable name, you will get this constant. Okay, you'll get this content. So usually, because uh, this one you want it to be shared by different class, so you have to put that static there. If not, if you don't have this one, you can only do a little a equals new a. Okay, and then you a may have this content AA. Okay, that is an instance constant. Okay, now let me actually spend some time to explain instant variable and the class variable. Okay, what is instant variable and what is class variable? Let's look at class variable. I'd like to look at some example. Here, I may have something called circle. Okay, I may have something called circle, right? And circle itself is a class. Okay, and they may have two variable. One may be double radius. Okay, and another part is called integer number of circles. Okay, let's assume we have these two data type. Okay, these two data. And this number of circles, you want it to be shared by different circles. So I put a static in front of it. Okay. And then this one is considered to be a class variable. Okay. So basically, I have a class called circle, right? And then I have a class variable called number of circle. And this class, I can create several circles, say C1. If you actually do C1 equals new C, that create a new circle C1. And this new circle C1 has its own radius. So you can actually have a variable called C1 dot radius. Okay. Same thing, I can create other object called C2. It's also another circle. And it also has the C2 dot radius. Okay, so this one, radius is an instance variable. Each circle have different radius, but the number of circles have been created will be the same. It actually the same copy because I declare it by static. So this one actually is a shared copy. So share variable among different objects, we call it class variable. Okay, and that usually is used to store or to collect the data useful for the whole class. And when you actually access it from outside, you actually do circle that number of circles. Okay, this one is the class name. Class name dot the variable name. Okay, class name dot variable name. Okay, so this one is the class variable and instance variable. Remember, class variable is shared for the whole class. Instance variable belong to the object. Okay, and we won't discuss the method here. Okay, we save it for the later chapters. Okay, so that's constant. The next one, operators. Operators, remember division is more important. Division, if you have a single slash division, it means you have a 10 divided by 4, you return 2. So it only take the Q, the quotient portion. The remainder won't be safe. Okay, the remainder won't be safe. So actually it's a truncation operation. You take division and then you return only quotient, no remainder. Okay, and percentage sign means modular. Modular is the remainder. So 11 divided by 8, you the remainder is 3. So modulus is taking the remainder. Division is taking the quotient. Okay, but if you had double, any one of the operand is a double type, then actually is real division. Any of one of it actually is a real division. Okay, so when you have a real division, the result will be a double type. Okay, the result will be a double type. And also, if you have the arithmetic operation, uh, have different type mix. If they are all number types, they will all be converted to integer. If all of them are integer type, long integer or double integer, I'm sorry, long integer or short integer or by integer, they will all be converted to integer. Will all be converted to the longest integer type. So usually it will be integer or long integer. Okay, they are double type, I'm sorry, if they are 14-point type, they will be converted to the longest data type. That usually is the double type. But if the arithmetic operation say plus sign, it is actually mixed up with the string, then it will be converted to string. So string is a wider range variable type compared to the numbers. Okay. So arithmetic operation. So here we have 3.0 divided by 4. 3.0 is a double type and 4 is an integer type. So this one end up in double type. 3 divided by 4.0, this one is a double type. Okay, any one of the operand is a double type, you will end up with double type. Here I have the 3.0. There is a casting. Casting will have a higher precedence. So you will convert the number to 3.3 in integer type divided by 4. So this one you end up with 0 because you have the integer 3 divided by 4. You end up with the value of 0. And this one you have 3, you can cast it to double type. So it's 3.0 divided by 4. You end up with 0.75. Okay, and this one you have 3 divided by 4 because you have the parentheses, so it will be rounded to 0 and then you will convert it to double type. Okay, and that is 0.0. Okay, okay, Boolean data type. Boolean is true or false. It represents the condition, it represents the selection. Okay, and Boolean, you have Boolean value, it will be only two value, true or false. And you have Boolean variable, you can assign some Boolean value to a variable. And you have Boolean expression that need to do calculation to determine whether it's true or false. And you have Boolean function, you make a function call, and the function call will return the Boolean data type. And these will all generate Boolean value. So in some location that you need to use Boolean value, you can put either Boolean value, Boolean variable, Boolean expression, or Boolean function inside there. Okay. And Boolean type. Boolean type is a logic type whose value are true or false. Okay, you can create a Boolean variable, pass Boolean parameter, and return Boolean value from methods. Okay, so here there are different type of this condition. And remember, if you have a variable, the variable itself is a Boolean value. So you don't need to do if parenthesis minor equal true. Okay, no need. This represent checking for minor equals true. Okay, and same thing over here. If I love CS or not expensive, it is equal to what? You check in I love CS equal true or not expensive equal true. Okay, so that will have a parenthesis for checking. But these are not needed. Okay, these checking for true is not needed because the minor itself will return a true value or false value for you. Okay. Next one is De Morgan rule. Okay, De Morgan rule is used to convert your Boolean expression to a different format. So you may have a original expression A and B or A or B. So A and B will be equal to not A or not B. I'm sorry, this one is a negation format. Okay, this one is negation format. So this one is not A and B. So this is not A and B. So here that means is branded. Okay. These are the Java expression. You can also do Boolean algebra type representation. So you have some Boolean variable x. I'm sorry. So let me choose. My touch screen is not that sensitive. Okay, so you have x and y. Okay, in Java you write something like this. In Boolean algebra you do x dot one single dot with y. Sometimes even you can omit the dot. Okay, sometimes you can even omit the dot. Okay, now you have not x and y. Okay, you can write it as not x and y. Okay, so these are the notation for your not x or y. And if you want to do De Morgan rule, you break the bar. Okay, change end to or, and this one will equivalent to x bar or y bar. Okay, so I'm sorry, this one will be x bar or y bar. Okay, so not x and y equals not x or not y. Okay, okay, these are called De Morgan rule. And same thing, if you have x or y, and then you actually take De Morgan rule and negation, and you try to find its De Morgan rule, you will be breaking the bar, change the function to end. Okay, so your plus change to your or change to end, and the end change to or after you taking the bar. So basically, this one becomes x bar and y bar. Okay, that's the De Morgan rule. What is the meaning? Okay, say here. This one is means like let's assume that x is a boy is handsome, right? And y is the boy is rich. Okay, so a boy is not handsome or rich means he is not handsome and he's not rich. Okay, a boy is not handsome and rich means either is he's not handsome or he's not rich. Okay, this is the way you actually remember De Morgan rules. Okay, now let's go back to the slides. Okay, that's the De Morgan rule. Okay, now let's go back. Okay, that's the De Morgan rule. Okay, this operator, you have to remember them. Okay, and then and or not. It's not hard. And these are the last law of the Boolean algebra. Same thing. More important part is the distributive law. Okay, the associative law is not important. The distributive law is more confusing, especially this a plus b dot c equals a plus b dot a plus c. Okay, this usually you will not recognize it. This a dot b plus c is easy. A and the b or c equals a times b plus a times c. Actually, this is easier to remember. This one is harder to remember. Okay, but that rule is important. We see that in the multiple choice 2015 for this one. Okay. So this different rule you have to remember. Okay. Now this one is called when we actually try to verify a logic function, we may need to use this one called truth table. Okay. There are 3 way or 4 way to solve the truth table. One is use this truth table to for it. Okay. There are 3 or 4 way to solve a logic expression. You can use truth tables to solve it, pull the identity. That's one way. You may also use the domain, 2D domain or 1D domain, draw a regional diagram to solve the problem. You can also use the plugin to solve the problem. So facing a logic problem, you have 3 way, 4 way to solve it. So here, let's look at this one called truth table, truth table. So if you have A and not B and not C, okay. So here you have A, not B, not C. You just list down like this, okay. And then you will have the 0 and the 1, 1. You end up with 0, okay. So that's the way you do it. So you finish all of the A rows. You will have the truth function, a truth table for a column. And if you want to pull identity, you have to have 2 columns matching the all of the different rows, and that will pull the identity for 2 functions. So each column is considered to be a logic function result. Okay, let's try this one. Okay, we have A and B, or not A and B. Okay, let's look at this one. Okay, so here we have this one. We have X or Y, right? And not X or Y. Okay, change to Boolean logic. Okay, you have the this one called X or Y. I'm sorry. You have X or Y and not X or Y. Okay. So 2 way to solve it. This one is you actually can consider it is A and not A, and you already get 0 if you remember the equation, the law for the Boolean algebra. Okay. Or if you do this one, it will be X plus Y and not X and not Y. Okay. And you try to do it, you will find out this one will also end to 0. Okay. So that's the way you solve it. So this one actually is always false. Okay. So this one will give you always false. So the next one is like this one can be solved by the regions. Not A less than B and not A greater than B. Okay. Let's look at the uh, let's look at this problem by looking at the number line. Okay. So basically you have let's assume that you had a 2D domain. You have A and B and you have not A greater than B, right? And not A less than B, okay? So basically, A greater than B is what? A greater than B, you have the dash line. Okay, A greater than B is this side. Not A greater than B, actually it's a solid line and this way, right? And this one, A less than B, A less than B is this way. And not A less than B would be the solid line and this way, okay? So solid line this way intersect with solid line this way, it will end up on the boundary, you only have the line. So this one equivalent to A equals B, okay? This one equivalent to A equals B. Sorry for that, okay? This one equivalent to A equals B. So two ways to pull the identity for the logic. One is using the truth table. The other one is using this one, using the number line analysis. And there's another third one is using the Boolean arithmetic, Boolean algebra to do theorem, to do reduction, okay, to simplify the equations, okay. So this one is assignment operator, and that's not hard, okay. But basically, you remember the rule, okay. And here the precedence, you should memorize it. Usually, something will go wrong. Will be the division, and maybe the unary operator, maybe the casting. Casting to be done early, okay. And parentheses take over everybody in precedence. Okay. Next one, this one ASCII code. Remember where are the zone for the ASCII code. Sometimes it's important. Oh, and also ASCII code, when you have a character, those characters are supposed to be in ASCII code format. And ASCII code, let me see, okay. The character char type actually is a 16-bit data. And for these English letters, they are called ASCII code for 8-bit ASCII code. Okay. But when they store in the memory, each letter are still stored in 16-bit format. Okay. So when you have a plus sign, minus sign, these different character type will be have like integer. It said that they are unsigned integer. Okay, it said that they are unsigned integer, but when they do arithmetic operation, they are considered to be integer, and they follow the rule for integers to do arithmetic operation. So sometimes you will take advantage of using these different character value for arithmetic operation to create the right symbol for you. For example, if we want to generate a random character, we can basically do this. Okay, we can basically do this. We may have a mass function, right? So we have the mass that random, right? That will generate a number from 0 to 1, not including 1, right? So we need to actually times. We basically need to times. Sorry, let me erase this one. Too big. Okay. So basically, we need to times. We need to time 26. Okay. Okay. So and this is 26. Sometimes you can use a minus g plus 1, right? So this actually is using the character for arithmetics. And this one take quantization. You will create your number from 0 to 25, right? And then this is 0 to 25, so you need to add your ASCII code in there for A in there, so that will convert it to 65 to what? to 91, but not including 91. Okay, so basically you have 65 to 90 for G. Okay, 90 is G. Okay, 90 is G. But this one is in integer format. So after that, you need to change it to char type. Then this one is the perfect random character generator. Okay, but remember, the char type can be used for arithmetic operation. Okay. Okay. Here we have the class characters. So this class character, remember these different functions. It is quite useful maybe in FAQ. Okay. So you have to remember these different functions. You need to remember these different functions. Okay. And then here we have these different character methods. You need to remember most of them. And here we have the mass class. Same thing. You need to remember these different methods that will be useful in your exam. And this one, random number generation. So basically, we can generate a random number by using count, step, and baseline. So to analyze this again, you need to use the notation I used, okay, before. So basically, if you only have mass.random, you will create a number between 0 and 1, not including 1, okay? Then you times something, say times the count number. Then this whole thing will create 0 to count, but not including count, okay? And then you add quantization. It will create a number in numbers, okay? But in this range. Then you actually, what? You have this one actually times 2. You will actually create something like 0, 2, but up to 2 times count minus 1. Okay? And then you pass some baseline. Then that baseline will be the base value. So you actually will create the baseline plus 2. So basically, these are the number you generate. Okay. The last one will be baseline plus 2 times count minus 1. Okay. So these are the equation you need to remember for random number generation, and try to use that to match your problem need. Okay. So we are up to here, the generation of random samples, and then we have string. Okay, string is a collection of characters, and you have to remember that string is a reference type. Okay, string is a reference type, so string actually store the reference address, and string, when it assigned with a value, it is called redirection or assignment of the address to the variable. Okay, it is not actually changing the content for the string object. Okay, and string object stored in either the constant string pool or stored in a heap. Okay, and that actually is something you need to remember. Okay, so string similar to object. When you actually create a string, that string will be stored in the dynamic memory called heap. Okay, but the variable name will actually be stored with a address or hash code into it. Okay. And here are the important string method: index of, length, substring. And these different functions are very useful, especially the index of is very important. Index of can be used to find out the index for a certain character or a certain string, substring in that string. Okay, and you can also have the index of with a second parameter, that's the starting index. Okay, usually these are the important function that you will use in your AP exam. Okay, and they are also equals function. That's important. You check in the equality of two string. You also have the contains function. You also have the two lowercase, two uppercase function. They are all important. And they are also trim function that will take out the white space characters. That's also important. You have the split function that will convert a string into an array of the substrings. And those substrings will be separated by the white space characters. So these are the methods that you need to remember for string. Equal function check the equality of the two strings. So here are the important Java string functions you need to remember, and do remember. I think 1, 2, 3, 4, and 7, 8, 9, 10, 11, and 15. These are important. Okay, these are important. Unit 2, structured programming. Okay, structured programming compared to elementary programming is like elementary programming, we just talk about a data type and then statement by statement operations. Okay, structured programming, we talk about three things: decision, repetition, and the function call. Okay, three different things. Decision is if then else statement, switch statement, conditional statement. A switch statement and conditional statement will not be tested in AP exam. It is okay that in your FRQ you write some conditional statement. That is fine, it's acceptable. But you have to use it correctly. And this, but in the real exam, they only test you if then else. Okay, if else statements. So we have the if else, if ever, if while loop, for loop, and for each loop. There are also do while loop, but do while loop is not AP subset. Okay. So basically, if we have a 3 bonus question, must get all correct to for 5 point added to the grade. So there are 3 questions. If you get all the 3 questions correctly, then you will be added with 5 points. Okay. So here is the example. You have if bonus 1, bonus 2, bonus 3, 3 all true, then your grade will be plus with 5 points. Okay, and that's a single way of if statement. Now we have if else. If else, it can also be called as binary if statement. So you have a Boolean condition. Yes, you go right. Wrong. No, you go left. Okay, this kind of branching statement. So here we have if grade equals A, then you print out excellent. If grade equals B, you print out good. If grade equals C, you print out poor. Otherwise, you print out invalid. Okay, so this one is multi-way if else if. Okay, and it is considered that you have a single decision I'm sorry, you have multiple decision to branch out multiple way. Okay. Combination of if statement, and you can actually combine the if statement together. But remember, if you write the upper portion, it will be similar to you do the second portion. Okay. Actually, two are equivalent. So sometimes you read as the bottom portion will be easier. And here we have rewrite only if else. Okay, so we can rewrite this function to have only if else. So that would be simpler. Okay, then calling if you see a else symbol, the else actually belong to the closer if statement. Okay, it will be considered to be the same uh, associated with the same. So it's not associated with this if for a greater than 3. It is actually associated with the if and then b greater than 4. Okay. So this one actually, if a greater than 3, we do this two if else statement. Otherwise, it will jump out. Okay. And we, b greater than 4, c increase. Otherwise, d increase. Okay. And we have while loop and for loop. Okay. While loop and for loop actually, for loop is a special case for while loop. Okay. So basically, while loop, for loop will have initial condition, continue condition, and update condition. Okay. While loop, you only have the continue condition, but you can add your initial condition outside of the for loop, and then put the update condition inside the while loop. I'm sorry, while loop. While versus the for each loop. Okay. So while loop, we have we can have the left hand side, and while loop we usually use I as index, and for each loop usually we use a for each loop, and then we use what a, statement, and then with a element pick. And that element pick actually is for element, it's not for the index. So be careful about it. So for loop, essentially you have the for I equals 0, I less than 100. That I actually is an index. On the right hand side, integer cell, for integer cell in the location cell, that cell will be an element. It's not index. So these two you have to be sure that which one you use. Okay. So for loop versus for each loop. Okay. So left hand side for loop use index, right hand side use element. But remember, when you have the element, you don't have the index, so you cannot use for each loop if the index is important. While loop, you have a while loop, and then while value less than 28, we do the following thing. Okay. So the first number being printed is that I have the value equals 15. So I'll print now 15, okay? And the last one we'll print is like, okay, let's assume that we have the 27. Value of 27 will go in. We print now the value of 27. And then value increase. And you increase to 28 and you get out. So the last one you print now will be 27. So first one 15, second one 27. Okay. Okay, here another example. This one is a GCD algorithm. Okay. But if you don't know it, this one you will have to use the scoreboarding to solve it. Okay. But this one, if you know the operation, this one is finding the GCD for it. If not, you have to actually look into it and then use the scoreboarding to solve it. Okay. Okay. Next one. Next one we have for loop. Okay. And here we have for loop, and then we have A, B, C, D, E, F. Okay. And we try to each time print out a substring of 2 characters. Okay. And then so it actually you will print 2 characters, but each time you are increased by 1. So after the first character you repeat. Okay. So basically the result will be what? The result will be, let me see, you have the A no, you will have this C will be the answer. Okay. And here we have 2D, we have the inner counter, we have the outer counter. So this create a 2D indexing. Okay. Let's look at this case. Okay. Let me pick this one. Okay, so right here, basically your I is outer loop. So from 0 to n minus 1. Okay. In the inner loop, you starting from 0 to the outer. So when you have the inner to the outer, it basically will end over here. So it actually is this case. Okay, and every time you print out the outer, so basically you will print out 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. Okay, something like that. Okay, but actually it doesn't have the print line. Okay, because you have doesn't have print line, so you will print 0, 0, 1, 0, 1, 2. So you print out B. The answer will be B. Okay. Let me see. Oh, okay. Sorry. This value is actually. Let me see. Oh, okay. So actually, it print out the outer. Okay. It print out the outer. So it's starting from. It actually will print out the row number. Okay. So the row number. Print out the row number. Okay. I'm sorry. So basically, it will print out the row number. I'm sorry. It doesn't print out a column number. The one actually I told you is print out a column number. So basically, this one should be print out the row number. So basically, it should print out 0 and then 1 1 and then 2 2 2 and then 3 3 3 3. Print out the row number. Okay. Sorry for that. I didn't recognize that it actually is a row number. Okay. Sorry. And then the next one. Next one here is like method. So method we have the signature, and the signature including the public, private. That is called visibility. It determines who can call this function. Okay, for the signature, it determines who can call this function. And static decide whether it's class function or a instance function. And double is the return type. Okay, and then method name and then argument. So when a function is called, it usually will match the function name and the data type. Okay, so when we check if a function is correctly overloaded or not, we basically check the name, return type, and the argument type. Okay, and argument type, if it is compatible, if it is the same, then the variable type, variable name actually doesn't matter. It is considered to be the same function when it is when overloaded. Okay. Here we have the instance method. Instance method, you don't have the static. Okay, you don't have the static modifier. So you have a public double potential at double x double y. Okay, that's the instance method. And we have this one as the call stack. Okay, call stack. We basically each time you call a function, the local variable, the return address, and the parameter will be pushed into the stack. Okay, it will be pushed into the stack, and then when the function finish, you pop them out. So when you trace some function, or sometimes usually is recursive call, you have to have this call stack in mind. Okay, you should have this aware of the call stack. Otherwise, you may answer the multiple choice problem in the wrong way. Okay, and recursive call. Recursive call actually is a function that call itself. Okay, but remember, each time you call a function, you have the call frame being pushed into the stack. So basically, you have to consider that the reference environment of two function call will be different. So each time the n value, okay, will be different when you call recursive call, and you have to know that what is the reference environment you have right now. Once the call finish, you pop up, then it will have different reference environment. Okay, it will have different reference environment, and then you have to be aware of current n is which one. Okay, then you can actually print out the right data if there is a printer. Okay, overloading. Overloading, basically here we have a draw box function, and there is a no argument draw up, and there is a draw box with the integer, two integers. So these are two draw box. So if you have draw box with a single integer, that is actually a overloading function. But if you have a draw box with the integer x and integer y, that is not a overloading function. Actually, it will create a compilation error. Okay, because the compiler only check what? Only check the function name and the variable type. Okay, that's the only thing they check. Okay. Okay, let's have about 5 minutes break. Okay, we have been doing this for almost 1.5 hours. Okay, so I will have 5 minutes break and we will come back. Okay, because we have more thing to come. Okay, so here let me actually put a mark. We have 5 minutes break. We have 5 minutes break. Okay, and let's see. Right now it's five. Let's go back 5:30. Let's resume on 5:30. Okay, we have already uh, do this for 1.5 hours, almost 1.5 hours. Okay, so let's go back on 5:30. Okay. Longest data type that usually is the double type. But if the arithmetic operation say plus sign, it is actually mixed up. Okay, I'm back. Okay. Before the break, actually, I talk about the function call. Okay, talk about the function call, and we may have a main function. Let me simplify this. So something I may not write it. Okay. So I have a f function and I call f of 3, right? And this f function actually has an integer variable x, right? And I may call g function with 2, right? And then there's a g function, actually it may have an integer g, right? And then it may print it, okay? Okay, anyway. This is a simplified version. So basically you will have a stack, right? And then you will actually put your number, actually you will have a call frame for your main function, okay? And then you will call your f function, okay? So there will be a call frame for f function, but the parameter will be put on the bottom, and then you have the return edges for the function call. Return edges means where you call return to the function, okay? After that, you put your local variable here. So local variable, because in your f function, sometimes you will declare some local variable here or here, okay? So you will grow, okay? But after that, you call your g function. G function will be put into there. So your g will be put into here, some variable. So something put in here is exactly the same as the first line of the parameter local variable that you declare. Okay, but once you pop it up, you finish your function call, you pop the data out, the number will not exist. Okay, so those are local variables. The lifetime, we call it scope, is only within the function call. Once the function call finish, the x will not be existing. Okay, so basically you need to check when you are asked for a certain when you are checked for a certain function call, you have to check whether the variable is existing or not. If not, then you should actually uh, consider it is not existing. So the value outside of the function in the main function or even in global variable will actually have different value, okay? Unless that you actually pass it as an object or something, then you all return as a value, then the outside function will be actually get it, okay? So that is important. That's probably the most important part for function, okay? Now we are on the data structure, okay? We finished the elementary programming. We finished the structure programming. That actually is the basic portion for programming, okay? Now we start to look at what are the data structure. And data structure is the organization of your data. And the purpose of having the data structure usually is to help you to write program. And in fact, if you don't have any data structure, the program should still work. Okay, should still work. Just like if we have a million of the boxes to ship from one city to the other, you will actually always be possible that you ship one box by another box. It should still work, right? You still be able to ship it in that way. But it is not actually the most efficient way to do it, right? So we actually put those boxes into a cabinet, right? And those cabinet being loaded onto a train. So train with multiple cabinet, and each cabinet has multiple boxes, right? That's the data organization, and we call it data structure. So data structure exists because of the convenience of programming or convenience of things, but in fact, the total amount of memory space needed to put those data in will be the same. Okay, will be the same. Okay, now let's get started. So the data structure being discussed in the AP Computer Science A pretty much will be list, array, and 2D array. Okay, so basically we need to know about array, list, and 2D array. Okay, that's the main data structure we talk about. Some nonlinear data structure, like tree will not be discussed. Queue stack will not be discussed. And some other data structure will not be discussed. We primarily working on list and array and 2D array. Okay, so the data structure. An object is also considered to be one kind of the data structure. It is considered to be heterogeneous data structure because you can put a collection of different data type into a object. Okay, array is considered to be a homogeneous data structure. It actually contains all data of the same type. Okay. Okay, so an array you can have 1D array, and each array each array may have multiple elements, and each element can be accessed by some index. So the value we call it element, and then the address we call it index. And index usually it's used to access the data. Okay, so and 1D array in initialization, you can declare double bracket data equals new double 25. So that declare a 25 element data type. Okay, 25 element double array. Okay, so you can declare like this, the first one or second one or the third one. Third one actually you declare but did not initialize. Okay, did not initialize. So when you declare a double bracket data and do not initialize it, that means the data will be stored with the value of null. And null means no address. And no address, you cannot operate the data as normal array. No way that you should operate like a normal array. Because if you try to operate it like a normal array, you will get null pointer exception. Okay, because at that time, even the array object had not been created. So you need to wait until data equals new double 25. Then the object for the array will be created. Then you will be able to operate the data as an array. Okay, one dimension array. I think this one's easy. Array length. Length is a data field, just like any other object which has some data field, some variable, some instance variable. So length is an instance variable. Okay, but compare the string. String is immutable. So string's length has parentheses. That is a function. And in arrays, you use size parentheses, and that actually is also the number of elements, but it actually the function name is size. But remember this, length with parentheses and the size with parentheses. These three are used for array and array list and string respectively. So actually these cannot be mixed. If you mix it up, you'll get 1 point deduction in the FRQ. Okay. So the index starting from 0, always starting from 0. So you have a array length of 25. You will go from index of 0 to 24. Okay. Length is not a measure for an array. It's actually a data field. Okay. But for string, length parenthesis is a measure. To traverse through an array used for each loop, and that each time you pick up a element, but that element actually is a variable, a local variable. Okay, that element is a local variable, so it is a copy of the data. It is not an original copy. So if you update it, you may not be able to update the original element in the original array. No, you will not be able to change the data. You actually copy the data out and do some operation. So if you want to use for each loop to update your original data, there is only one way. You buffer it in this local variable, and you try somehow to change the original data type. Okay. So here there are many things that you can do with the array: counting element, printing element, summing element, swapping element, finding the maxima for them, insertion of the element in an array, or deletion of the element in the array. These are all important when you go to AP test. At least one problem in FRQ will be testing this simple algorithm. So counting, you set up a counter, and then each time you have the increment. Printing, you access each individual element and print it out. This, we call it the traversal, 1D traversal. You just get each index and then use that index to access each element. Okay. Summing, you set up a total number and you actually just add each individual element to the total. Okay, that will do. So the way we do it is like we actually create a total, and then we use a for loop, and each time the post is the index for the value array, and you actually add that element result to the total number, and the total number will be the sum you want to have. So here we can also use while loop, will have the same effect. Okay, and while loop sometimes makes some sense actually in string operations. Okay, because string operations sometimes the increment is not one. The increment could be random. Okay. Okay, swapping element, we call it the rotational swap. Okay, so rotational swap means, let me show you in the whiteboard. What is rotational swap? We have two data. We have integer. We have two data. We have integer. Sorry for that. I have to click it. Okay. We have integer x and integer y. We want to swap, right? So the way to swap it, you actually need to create a temp variable and store x to t, and then you change t by y, and then you change y by t. Okay, so basically you have t, you store your x to t, then you store y to x, and then move t to y. So this is called rotational swap. And there's another way you can do it. Is like you have the x, you copy to A, you have y, you copy to B, and then you actually swap it. Okay, this is called buffering swap. Two way, each way will be good. Okay, but usually when you do selection sort or something that swap based sort, they are using the rotational swap. Okay, and rotational swap is also good for if you have the shift function. Okay. Okay, next one is to find the maximum and minimum. Maximum, here we have two ways you can do it, okay? Finding maximum, actually you set the first element, store it to the minimum, okay? And then you actually every time compare, if a number actually smaller than the minimum, you update the minimum. This is the way you calculate the minimum. And then here we have the finding the maximum, but there's only different by the greater than sign. Okay, and there's another way you can do finding the maximum or minimum. That is, you use the integer that means or integer that max. So if we want to find the minimum, you should do integer mean equals integer that max value. Okay, after that you do what? you do for integer I less than array a the length I increase, and you do if the a's I value actually is actually less than mean, then you say your mean equals a's I value. Okay, this way you actually use this. Okay, here you have the I equals 0. Okay, that's another way you actually can find the maximum or minimum. Okay, that's another way you can find maximum or minimum. Okay, this one usually each year you may have one problem, or every other year you may have one problem finding maximum or minimum. It may be of different type. Okay, it may be have some uh, change. Okay, and the next one is the array list. Okay, we talk about arrays. We finish array. Now we start to talk about array list. An array list is a kind of list. Okay, and it's actually is one of the data type in the big Java collection framework. Okay, Java collection framework, including iterable interface, collection interface, and you have list queue set interface, DQ is double queue, sorted set. Okay, these are different interfaces, and they are solid or concrete classes as well. Okay, array list implement list. So usually when you use array list, you can almost all use the list to as a reference. Okay, and this is a reference, so there's no way that you can create a list object. Okay, list object is impossible. Okay, so here are the function you need to remember for array list, especially the set function, the index of function, the size function, the remove function. These are the important functions you need to remember. Okay. Okay, here is the comparison for array and array list. Okay. The way they access it is different. One use the array indexing scheme, the other one use the get I scheme. Okay. Second, the length, the number of element is different. Array you use the length. Array list you use the size with parentheses. Okay, and right here for each look almost the same. And remember here you have ARR, the ARR or ARR list over here. Most of them need to be iterable. If they don't have the feature of the iterable, you cannot put it into the for each loop. Okay. So array is of fixed length, set when it is created. Must keep track of the last slot that array is not full. Must write code to ship element if you want to insert or delete. Array list is more flexible, but in fact, array list in storage is also the same as array. So, in terms of complexity or time complexity, they are almost the same. But in terms of convenience of use, array list is better. Okay. Insertion and deletion. If asked to insert or delete for arrays, you will need to create a new array. Usually I call it the destructive operation. So when you face destructive operation, you need to back up something. So later, if you need to restore the data, you will be able to do it. Okay. So for insert and deletion, you are updating the array. So it is considered to be a destructive operation. So you better back up your array before you do it. Okay. So when you do FRQ, you have to look at it whether it's operation on the original array list, or you should return a new one. If you need to return a new one, that is considered to be the non-destructive operation. I'm sorry, if you need to return a new one, it actually would be the non-destructive operation. Okay, if you don't need to return a new one, you operate on the original data. It is destructive operation. Okay. And here we have array list. So we add A, add B, add C, and add D in the zero. So the data become D, A, B, C. Okay. Remove 3, D, A, B, C. C is 3. So you have D, A, B, right? And then you add E in front of D. So you have D, E, D, A, B. So the answer is C. Okay. Another array operation, you can do replace. Replace, you will replace one value for the entire list. Okay, but if you have the replacer will replace everything inside the list. Okay, that is more powerful. Okay, that's replace all. You can have the string, so each time you can replace everything inside the string will be replaced. Okay, string array list will be replaced. 2D array. 2D array is array of array. So basically, the rows are in an array as well. So the nums actually pointing to the row arrays, and each row array pointing to multiple column elements. Okay. So 2D arrays are array of arrays. Here we have array as table. So 2D, you can consider it to be an array of table. So here we have 3 by 3 table, and we put a X into the element 2, 0, element 2, 0. And here we have column and row of different size. Okay, this is not a square. Okay. 2D operation, here we have this. And then up to Alt 1. So Alt, what will Alt do? Alt actually pass a C. So J starting from C plus 1. So we have 1. So J starting from 2. So basically, we will copy 5, 6, 7 to 3, 4, 5. And then you copy 7, 8, 9 to 5, 4, 5, 6, 7 location. So the result will become like this. Okay. K-graph. K-graph operate on the upper triangle or lower triangle. So here, remember usually it is used to explore the relationship of the element in an array or something like that. Okay. But remember that if you need to access an array, say here we have 4 by 4 array. I'm sorry, we have a 4 by 4 2D indexing. Right? If we want to traverse the upper triangle, okay, if we want to traverse upper triangle, we should do for integer I equals 0, I less than this one, right? So it's actually n minus 1. So n is the length of the array matrix A, okay? Number of column rows, and I increase, right? And then you do for integer j equals I plus 1, okay? And then j less than n, and j increase. So this one will give you the upper triangle traversal, okay? How about lower triangle traversal? So lower triangle traversal, we actually will traverse to here, okay? So basically your I starting from 1. So for integer, I started from 1. I less than n. I increase. How about your j? Your j for integer, j equals 0, and j less than I, and then j increase. Okay, two way you can actually do comparison but among elements. Okay, so basically, what are the elements? If we have the element A, B, C, D, we try to explore the relationship between A, B, C, D. You should have the relationship of A to B, A to C, A to D, A to D, and then uh, B to C, B to D, and then C to D. So this one, upper triangle or lower triangle, will all explore the relationship among the elements. Okay, and this one actually usually recently every year there will be one FRQ asking some question like this. Okay, so you have to understand how you can use this upper triangle or lower triangle for these different operations. Okay, so that is important. Now the next one, we move on into objects. So we have the objects and we will finish with the algorithm. Okay, so now let's continue on the object. Okay, for object-oriented programming, there are three important things: the basic class construction, the inheritance, and the basic class construction will have the encapsulation idea, and then you will need to take care of the inheritance and polymorphism. Three main topics in a class construction. And outside of a class, you need to think about the has a relationship, is a relationship, and also you need to have the abstract class and the interfaces. These are the important topics in object-oriented programming. Okay, so first let's look at what is null operator. Null is a reference that does not refer to any object. So field of an object that refer to an object are initialized to null. So when null, it actually assign a zero value to the pointer. Okay, and the real pointer to the an object means no data associated with that reference. Okay, so here you may have an array of objects, but it actually doesn't point to anywhere. Okay, you may have an array list, and many elements of them actually do not have the object as well. So method header. For each header, we have the access modifier, return type, method name, and parameter list. Okay, and these are used to check if two methods are the same, or are you calling the right function or not. Okay. So type of the method, we have constructor, accessor, mutator, and static method. Static method is a class method. Accessor, mutator are the instance method. Constructor is not a member. It's not a member in your class. So it is not inherited. Okay. But your data and methods are your data and your data and your methods are member functions. Okay, your data and your methods are member field. So you do inheritance, they will be uh, taken over to the subclasses. Constructor, no. Constructor for superclass will be run once, but it is not a data field. It is not a function to be inherited. Okay. Okay, so some methods in the driver class. Methods in the driver class are usually all static because they are not instances of the class. Okay. A method in the driver class usually is used for what? For testing of the class or of the object. Okay, so driver class is because it actually is not will not be invoked by from some object. So they are usually the class methods. And class method is good as the utility function that actually help you to test some other functions or some other objects. Method overloading. To overload a function, you need to have the same function name. Okay, and the parameter list should be different. So it's same function name, different parameter list, and sometimes same or different return type. Okay, and return type is irrelevant to determine whether it's overloading or not. Inheritance. Inheritance is where subclass is created from an existing superclass. And the subclass copy or inherit a variable and method from the superclass. And subclasses usually contain more than their superclass. Okay, so superclass is the shared property, of the subclasses. So it is the simplest portion, and the subclasses are bigger, more complicated, and more specific. So that's why the subclass use the word extends. Extend means make it bigger. It has more data field than the superclass, and that is inheritance. So inheritance basically like we have a core feature that's shared by different classes, and we put it into the superclass. And for the subclasses, we actually put something more in addition to the base set in the base class or superclass. So class hierarchy, okay, which one is true? Superclass should contain the data and functionality that common to all subclass that inherited it from the superclass. Yeah, that's actually about right. Let's keep it. Superclass should be the largest. No, superclass is the least largest. It's the smallest. Superclass should contain the function, data and function that only require for the most complex. No, it should be the shared property. The superclass should have public data in order to provide uh, pub access to the entire class. No, actually, usually you don't do that. Okay, superclass should contains the most specific detail. No, it shouldn't contain those details. So answer is A. Okay, subclasses. Subclasses copy everything except what? Except the constructor. Okay, constructor is called but not being copied. Okay, inheriting instance method available. Subclasses cannot directly access a private data field or private function from the superclass. Subclasses must use the public accessor and mutator to achieve to get access to the data from the superclass. Method overriding and the super. If a method has the same name and the parameter list in both the super and subclasses, the subclass method override the superclass method. To invoke the method from the superclass, the keyword super should be used. So when you use the super, that means you know which function you are calling. It is the superclass function. Okay. If not, if you don't use the superclass, then we will find the first implementation of the function that is closer to my current object, not current reference, closer to current object. Okay, so based on the object, the dynamic linking based on the object, not based on the reference name. Okay, so rule for subclasses can add new private instance variable, can add new public private static methods, can override inherited methods, may not define public method as private, may not override static method of superclasses, should define its own constructor, cannot directly access the private members of each superclass, must use accessor or mutators. Okay, declare subclass objects. Superclass variable can reference both superclass object and subclass objects. Okay, which of the following is not valid? Usually it is wrong if you have superclass reference. I'm sorry, you have the subclass reference with the superclass object. So the answer would be D, this one, undergraduate X equals new student. Okay, that one is wrong because you have the subclass reference taking the superclass object. The superclass object is simpler, but your subclass reference may demand more, and it is not compatible. Polymorphism. Polymorphism has 4 different definitions. You have a casting, the coercion polymorphism. You have an overloading, overriding of polymorphism. You have the membership hierarchical polymorphism, or we call it inclusion polymorphism. And you have the last one, parametric polymorphism, or generic programming. Okay. Type compatibility. Only polymorphic if method is overridden. Okay. This is fine. Abstract class. Superclass that represent an abstract concept. So sometimes, for example, like area is a abstract concept, but it means different thing for your square, your circle, your rectangle. They actually mean different thing. Okay, when that happens, actually you can keep the function as an abstract function and put it into your abstract class and put that abstract class as a superclass for rectangle and circle. Then you can actually run the superclass and get access to different circle or rectangle type. Okay, so you can have both abstract method or non-abstract method. Okay, but if there is some abstract method, this class must be abstract. Okay, interface. Interface is a collection of related methods whose header are provided without implementation. Okay, so interface only has two things, two possible things. The first one not important. It is the constant. Interface can only have constant, can never have variable. And then second, you can have a public abstract method. And if you do not write public abstract, the Java will add it for you. Okay, so actually it will add it for you. So that means that interface just a collection of function, and usually interface means some capability. So usually the name of the interface is clonable, sortable, and then comparable, runnable. Usually those are the name for a interface. And you give them a function, and everybody under the interface must have the capability. Then we call it interface. So interface is a capability. And then your abstract class or class, you can have only one extension. So you can have only one superclass. Okay, but you can have multiple interfaces. That means you can have different capability. That's just like you can have only one school. Say you are associated with Washington High School, so you actually is as a subclass for Washington High School, right? But your capability, say athletic capability, or swimming as a capability, or uh, instrumental capability like piano capability, those are interfaces that you can add on yourself, right? But the school you can only have one. Okay, that actually is the interfaces. Okay, so to use the interfaces, usually it is a enabler. You add those functions, you can do something. But interface, you don't have the implementation. So you still, when you participate some interface, you implement some interface, means that you are willing to implement the function in the concrete class. So interface become a membership. Okay, when you actually do implement the comparable interface. That means you need to implement the compare to function, and then you make your class sortable. And the sortable is the advantage. You can use the array.sort to sort your objects. Okay, if you implement the comparable. So interface give you the capability, and your class need to implement it. After you implement it, you get some feature, and that feature allow object of all the membership to all the participate in that interface be able to operate in the same way, and that we call it a capability. Okay. So use object class for object that is application specific, but incomplete for subclasses. So both interface and the object class are memberships. Okay, and object is an incomplete class, while interface is a capability add-on list. Okay, that's the main difference. Consider interface if the methods are suitable for your program, but also equally applicable in various functions. Interface cannot provide implementation. Object class, yes. Object class is a incomplete class. Partial result. Okay. List. This basically means the same as array list. Okay. That means that whatever array function in the array list, it almost is there in the this interface as well. But this interface, you cannot instantiate anything. But you can create basically you can create a array list object and then assign it to list reference. That actually is okay. Okay, we are now at Unit 5. Okay, Unit 5 is algorithm. To prepare your Unit 5, the best way to do it is that over the year, your teacher may teach you many algorithms. So you should have a collection of them. Then memorize the version, help you to do it, in the exam. So for me, today I will show the key functions. The first one, linear search. Okay, linear search you do one by one. You have an array, and then you have a key, and you check each individual one. If there is a match, you return the index. If the whole array you did not have the match, we return -1. Okay, that's the linear search. Okay, you have to remember this one. Then the next one, binary search. Okay, binary search, you are given an array. Then you have a key that you want to match. Then you need to calculate the low and high. Now let's discuss this low and high. Okay, let's discuss this low and high. So if you have a odd number, if you have the odd number element in the list, okay. Okay, let's assume that there are 9 elements. Your low starting from 0, your high started from 8. Okay, so the first one, your mid value will be low plus high divided by 2. So odd number, you get this one as a first mean number. If you have the even number, say we have an even number, so here from 0 to 7, this middle one will be 3. Okay, because you have a 7 divided by 2. 0 plus 7 divided by 2, it will be 3. The middle one will be this one. So even number, the mid value belong to the lower half. Lower half. 2 halves are of the same size. The mid number belong to the lower half. Okay. Odd number it is right in the middle. But let's consider the lower half is bigger. And this actually is the same for the merge sort. That's why we have to discuss it over here. Okay, your low plus high divided by 2, that actually give you the midpoint, and the midpoint belong to the lower half, and lower half is bigger. Okay, that's one way you calculate the mid value. And there is another. Okay, It is not used in binary search. Okay, this is another. This other way of doing it is using length divided by 2. So if we have 9 elements, if we had a 9 element, right? So you have 9 divided by 2, the length. So you have the array the length divided by 2, right? You end up with the middle value as well. That actually is 4. Okay? If you have 4, you have a divided by 2, you end up with also 4. And that one is over here. It actually is the starting of the second half. So that's assume this one is also starting of the second half. So you use n divided by 2 or length divided by 2. The midpoint belong to the second half, and second half is the longer half. So remember these two measures of determine the midpoint are different. For for the determination of midpoint. You have two ways. You can use the low plus high divided by 2. Okay, you can use the length divided by 2. Two way, they end up with different result. And for this binary search, we use the low plus high divided by 2. So the midpoint will be the lower half, and lower half is longer. Okay, so here we have the high greater equals low, or you can actually what? You can actually change to low. I'm sorry, low less than. Actually is we have yeah, you have the high low lower and then equals greater equals low. That means you do not have the crossover. Okay, you do not have the crossover. Or you have low less than high, not you less than equal high, then you don't have the crossover. Once you have the crossover, then the algorithm will stop. Okay, will stop. So each time you actually find the midpoint, compare the midpoint, and then if you actually do not have a match, then you move your high to mid minus one, or you move your low to the mid plus one. Okay, if there's a match, you return the mid value. Okay, then you return the mid value. Okay, so basically, you need to remember this operation, and each iteration you calculate the mid value first. Okay, each iteration you calculate mid value first. That is a binary search. Let's look at insertion sort. Okay, insertion sort is like this, but the key point for insertion sort, let's look at it. Okay, that here I just explain how insertion sort work. Okay, so given a series of number we have, let's assume that we have 5, 7, 1, 3, 8, 6. We want to sort this one, right? Insertion sort always what? As a sorted zone. Okay, the first sorted zone is here. Next one to be inserted is over here. Let's assume we have this in simple, right? And after that, we do comparison. We use this insert one, compare this one. If this one actually is smaller than it, so we keep this one. So we have the sorted zone like this for the first pass. Then the next sort to be inserted one will be this one. We compare 7 greater, move 7 to here. 5 greater, move 5 to here. And then we put 1 over here. So this becomes the new sorted zone. Then we have 3, 6, 8, 7, 6 to be inserted. So now we compare 3. And then we move 7, move 5, and 3 over here, we copy to here. When we actually have 1 less than 3, and then this is the sorted zone. So it comes to here. And then we have A and 6. A actually no shift. So next one we have 1, 3, 5, 7, 8. And that is the sorted zone. And the last one we have 6, right? 6 we shift. So the A being shifted to here, 7 shifted here. We put a 6 over here. Okay. So you in the multiple choice, you have to remember the basic operation for each sorting and searching. Okay. This is insertion sort. Let's look at the selection sort. So we have the same. We have the same 5713A6 array. Okay. Selection sort. You started with the element to be swapped. Okay. And then you find the whole array, finding the maximum minimum value. Then you swap these two. So the first pass we swap to here, and this one becomes sorted zone. Okay, the sorted zone is here. So the next element to be swapped is over here. Then we repeat this one, swap these two. So we have the sorted zone 13. I'm sorry. It's sorted zone. So sorted zone up to here. So the next one to be swapped will be 5. And 5 is okay. So we have the 1, 3, 5, 7, 8, 6. So this is sorted zone. Okay, and the next one to be swapped will be over here. So you have 1, 3, 5, 6 sorted. And then we have 8 and 7. And the other one to be swapped will be this one. And so then we have 1, 3, 5, 6, 7, 8. And it stop. Okay? So that's the selection sort. So selection sort, you study from 0, and each time you have a new to be swapped element. Okay. Next one, we have the bubble sort. Okay, bubble sort. We still have 1, 7, 1, 3, 8, 6. So we start to compare pair. Okay. So we do this one, we swap. So 5 compared with 7, no swap. 7 compared with 1, swap. So you have the 5, 7, 5, 1. 7 with 3, swap. So 3 over 7 with 8, 7 keep. 6 with 8, 6 swap. So the first one, the sorted one, will be this one. And then we compare this. 1, 5, swap. 3, 5, swap. 5, 7, no swap. 6, 7, swap. So we have this one sorted. And so on, we compare this. 1, 3, no swap. 5, 6, 3, 5, no swap. 5, 6, no swap. Stop. You can stop right here, but you can also continue. Okay, depends on your algorithm. Okay, that's a bubble sort. Now the next one is merge sort. So for merge sort, let's have a value. Let's have a value to make it binary. So here we have 5, 7, 1, 3, 8, 6, 4, 9. For example, okay, divided by 2 part, we have 5, 7, 1, 3 divided by 2 part. We have 8, 6, 4, 9 divided by 2 part. 5, 7 divided by 2 part. 1, 3 divided by 2 part. 8, 6 divided by 2 part. 4, 9 divided by. And then we compare 5, 7 merge to back to 5, 7. We have 1, 3 merge back to 1, 3. Where 6A merge to 6A, 4, 9 merge back to 4, 9. Then we merge 5, 7, and 1, 3. We end up 1, 3, 5, 7. And then we merge back, we have 4, 6, 8, 9. And in the end, we have 1, 3, 4, 5, 6, 7, 8, 9. So that's the merge sort. Okay. Each time we divide, divide, merge back, merge back, merge back, merge back, merge back, merge back, merge back. Okay, that's the merge sort. So here I explain the basic operation for the merge sort, and you basically need to remember all of these different sorting algorithms. You get the code from your teacher because my code represent my own understanding. Your teacher may teach different way, so I don't want to corrupt your memory. But you do need to keep studying these different. Uh, you do need to actually study these different algorithm because in the real exam you will need that. Okay, you will need that, and the best way is that you try to remember as many algorithms as possible. Tomorrow you will need that in the real exam. So right here, let's go back to this binary search on the slides. Okay, which of the following is not true for binary search of any array? Okay, let's check A. The method involved looking at each element in the array, starting at the beginning until, okay, beginning is wrong. Okay, so I think A is wrong. Okay, in order to use a binary search, the array must be sorted. Okay, that's fine. The method is referred to be the divide and conquer. Yes. The array of 15 elements require 4. Okay. Using binary search is usually faster than a sequential search. Yeah, so the answer A is wrong. How many execution? How many execution actually usually use the log2 function? You will find out because it's a binary search. Okay. And if you need to calculate a specific uh, array, then you use the and some key. You use you trace the data and then calculate the mean value every time, and you will find out how many steps you will need. Okay. So here, 600 element, 2 to the power 9 would be 512. So how many time? I would say 10 times. Okay, 10, 24. Okay. Consider a binary search algorithm search for an ordered list of the element of numbers. Which of the following choice is closest to the maximum number of times such a algorithm will execute its main comparison when it search 1 million member? 1 million member is what? What is 1 million? 1 million is 10 to the power 6. And to estimate 1 million number is what? 1 million equals 10 to the power 6 equals 10 to the power 3 times 10 to the power 3, right? And this one close to 1024 times 1024, right? This is 1K times 1K. And 1024 is 10 to the power, 2 to the power 10. So it's roughly about 20 times. Okay, roughly about 20 times. Let's look at the answer. Roughly about 20 times. So B, 20 times. Okay, selection sort algorithm. I explain how it works. Okay, you can do that. Okay, and I don't continue this one. Basically, you remember the basic algorithm. So here, in the array of integers contain the following elements. What would be the array look like after surpass? Okay, testing us for surpass 89, 40. So first one we have 89. If you select the minimum, we got -3. Let me see. Selection sort. Okay, let's assume that this one is descending. Okay, it actually did not say it's descending, but it looks like the answer is descending. So we swap 109 and 89. Okay, second one you have the second largest, so you swap 89 with 42. So it's 109, 89, and here you have the 42. Third one you have the 70. So actually you'll be 89, 109, 89, 70, 13, and 42, and -3 and 2. Okay, that would be A. Okay, selection. So okay, insertion. So we explain it. Okay, so this one actually I'll pass it. Here, let me know. Greatest number of change in position. Greatest number of the change will be the most. The most. It said that sorted biggest to smallest. So the one actually most ascending one will create a trouble. Okay, I would say it would be. Let me see. I say the answer would be A. Okay, it's more almost like ascending. Okay, the answer is A. Okay, insertion sort question, the worst case. Okay, this should be fine. Okay. Okay, insertion sort a note. This one should be okay. We cover this. Okay, so we cover by the example. Okay, recursion. Recursion actually, one thing you have to remember, two important things for recursion. Okay, usually recursion happen on the multiple choice. You have two ways to solve the problem. One way is to basically write down the recursive call function. Okay, the other one is actually you build a recursive tree. The two way you can trace the function. Okay, there are two ways you can actually write a function. So let me see. Let me find some problem for recursion. Let me try some function for the recursion. Okay, not here. Let me close this one. Okay, not this one. So that here, let's find some recursion. Okay. This one. Okay, let's do this puzzle. Okay, let's do this puzzle. So we have the puzzle n and m. M equals 1, return n. Otherwise, you have the n times n m minus 1. So look like this one is similar to what? It will be similar to a factorial calculation. So let's do this one, okay? Let me bring up my pad, okay? Make it smaller, put it to the side. Make it smaller, put it to the side. Okay, here we have a puzzle. We call 3, 4, right? And you have n equals 3, m equals 4. So this one we'll call n plus puzzle of 3, 3, right? So basically, this one is traced by tree, structure. Okay, traced by tree structure. And so that one n is actually so 3, right? N is actually 3. Then this one call this one, and you will be actually 3 plus, I'm sorry, times, not plus, times p times what? Times 3, 2, and then 3 times p times 3, 1. So p times 3, 1, you call it, you return 3. So basically, 3 times 3, you get 3 square, times 3, you get 3 cube, times 3, you get 3 this. So that one is 81. You get a C. Okay. So this one is a solution by tree. Okay. But this problem is not appropriate for using the writing the call function. Those kind of function called writing by call function will be tail recursion. Tail recursive function, it is okay. You do that. Okay. Let's pull up the problem in let me pull out the problem 39 in practice exam 2014. Okay, that one is a tail recursion. Tail recursion, you do function call only. Okay, so let me find that one. Okay, take a moment. Sorry for that. So that 2014 practice over here. And let me try to find problem 39. Okay, previous one, 39. And to make it smaller, but do zoom in the problem. Make the window bigger. Okay, this is a problem. Okay, this is a problem. And then I make my whiteboard smaller. Okay. For this one is different from the previous one. This one actually is a tail recursive function. After the recursion, you don't have any function call. No, any operation. So this type of problem, don't do tree. Okay, don't do the recursive tree. Here you actually have you try to run the recursion of 27, right? And if you do tree, it will be complicated. Don't do tree. Okay, so this one you will have recursion of 9, right? Because you pass the 23 divided by 3, 27 divided by 3, it will be 9. And then recursion of 9, you go into that is less than 10, so you become recursion of 18. And recursion of 18 will be recursion of 6. And recursion of 6 will be recursion of 12. Recursion of 12 will be recursion of 4. Recursion of 4 will be recursion of A, and that give you 16. The answer is D. Okay, this way you just write down the recursive call. So two ways you handle the recursive call. One is using the tree to do it. The other way is like this one, you do the recursive call function. Okay, that's about my review portion. Okay, if you have any comment, let me know. I actually do this for the first time, and I welcome any suggestion. And the tool that I use may not be perfect. Okay, so they may have something that still need to improve. Okay, and first thing is like I want to introduce my website. Okay, eCode24, or you can actually access my website ecacademy.us. Okay, this will lead to the same website, our website. And here we have home, we have live course. So live course is the course we are offering on a per semester basis or per quarter basis. Okay, if you are interested in that, let me know. Okay, and we also have a web assignment. All of the homework assignment will come from this Moodle school. Okay, and third one on our website, you can find a MOOC courses. Here you can sign up some video courses at a low cost. Okay, so these are what I have, and I do want to help everybody. And I also have a Udemy channel. Okay, but recently I did not put too many courses on there, so you can go Udemy to find out my courses as well. And here we have different courses, and let me know what can I help you the most. And I try to do this the night before AP comes out every year, and this is the first time I do the live streaming, and hope that it work well for you, and hope that you have a good score tomorrow. And let me know if there is anything that I can actually improve. Okay, so before I leave, let me keep my page over here. This is my website, my email, and my Facebook link. I'll keep this message for a while. And thank you for watching my video live. Okay, and I welcome any suggestion. Thank you. Bye now. Over here, so my website, my email, and my Facebook link. I'll keep this message for a while. And thank you for watching my video live. Okay, and I welcome any suggestion. Thank you. Bye now. You actually do circle number of circles. Okay. This one is the class name dot variable name. Okay. Class name for each loop, and then we use what a statement, and then with a element insertion and deletion. If X to insert or delete for arrays, you will need to create a new array. Usually I call it the destructive operation. So when you face destructive operation, you need to back up something. So later you